I would like now to give you an example of how to design a database. So how to design the set of tables that go into a database. And I will take a simple example that is familiar with many of you. That is how to design a registration system that keeps track of which students are registered in which class and who is teaching which class. So a very naive beginning can be the following. We say db define table. We give this table the name class, and we say, well, a class has a number. Let me use examples. For instance, the number could be CSE 183. Okay, a class can have a name. Okay, for example, web apps. Then the class can be in a year, which is maybe an integer. Okay, the class can have a quarter, which is a string. Okay, for example, this could be something like winter. A class could have a description, which is the catalog description of the class. Okay, and so on and so forth. And if we do something like this, we immediately notice a problem. That the CSE 183 that is taught this year has the same description as the one that is taught the past year and the one that will be taught the next year. That is, there is a lot of redundant information. We are mixing in a single table information that is that is peculiar to the individual offering of the class in a particular quarter, such as quarter and year, and information about the class that is true for many offerings, such as name, number, and description. And one of the basic rules of database design is that you do not want to repeat the information in multiple places. Because if you were to make a change to the description, for example, you want to make the change in one place only in the database. You do not want to have to update the description of all the future offerings of a particular class. You want to have one place only in which we will make the change. So let us think simply at how to organize the information about classes, offerings, and quarters. One way to organize the information will be the following. We have the notion of a class offering. Class offering, which corresponds to a particular offering in a particular quarter of a particular class. So this notion has a catalog class of which it is an instance of, right? It's an offering of a particular catalog class in a particular quarter. Okay? And so the quarter as information has, for example, the year and the name of the quarter. And the catalog class will have a number, it will have a name, it will have a description. Okay? There are two ways of thinking at these arrows. One is that they signify a sort of belongs relations. Okay, so a class offering belongs to a quarter and belongs to a catalog class. And another way is that they are sort of functions. A class offering is mapped to the unique catalog class to which it belongs. So you have a sort of function that can map many offerings, each one into their one catalog class to which they belong. Okay, it's like a many-to-one relation. There can be many offerings for the same catalog class and many offerings in the given quarter. But each offering has one quarter and one catalog class. Okay? So let's just stop at these and translate these into code. Okay, so now I have three tables. There is class table, which I can call catalog class to make it clear that it's the general offering. Okay, so let me shorten it a bit. Then I want to have a db define table, and I want to have here a quarter. Okay, and then I want to fill it in. And then I want to have my third table, which is db define table, and here I want to have an offering. maybe I should say class offering. Okay, so a catalog class has a description, number and name. So let me pull up the description. Okay, the quarter has a year and a quarter, but well, perhaps it's not very nice to call it quarter. Okay, I can call it season. Okay, so this will be enough for a quarter. Now a class offering has well, maybe it has a number, okay, which is an integer actually at our university at least. But the real thing that I need to do now is represent these two arrows. How do I represent the fact that this class offering is associated with a single quarter and is associated with a single catalog class? So when you define a database table like this, a catalog class, these tables have also an extra field called ID. Okay, so this table, like all tables, will have an ID field. So if I want to refer from the class offering to a catalog, to a particular catalog class, I can say, for example, field, and I can say catalog class ID. So I want to write in this table, in the class offering table, the ID of the catalog class to which it refers. Okay? And the way to declare it, because we need to declare it as a type, you know, I mean, if we wanted, we could write integer. But this would not be a good idea. The number is actually an integer because IDs are integer, okay? But the way to write this is to say that this is actually a reference to a catalog class, okay? This tells the database, yes, it will be an integer, but it's actually the integer that represents the ID in this other table of the catalog class to which this offering belongs. So the arrows in our drawing will correspond to reference fields in the database, okay? So now we can code also the other arrow from a class offering to quarter, and we can say field quarter ID. Okay, so the name quarter ID is simply my own convention. You could call it quarter reference, or you could call it whatever you want. That's not important. What is important is that the type is reference, in this case quarter. Okay, so this has to coincide with this for the arrow to work, and this has to be correctly spelled. Okay. Okay, so this gives us the very beginning of the organization. Now let us go back. Let us go back to our modeling of the registration situation. And now we have a student, and we want to say that the student is enrolled in a class. So here is our student, and so well, now we have a choice. Would it be correct to say that a student enrolls in a class, so that a student has a reference to a class offering? Well, not quite, because the problem is that the student can enroll in multiple classes, right? So it wouldn't be if an n-to-1 relation. If we do it this way, there could be n students in a single class offering. But it's not as simple as that. A student can be multiple ones, so we can't quite do this. So we could imagine that there is a way to do a double arrow, right? And the idea is of a double arrow, so of an n-to-n relation in which many students belongs to many classes. But the way to represent this is, in our database is actually to create another table that is called registration, which represents an act of having registered. Okay, so this keeps track of who is registered where, and the registration is for a particular student in a particular class offering. Okay, so the student has a name, an email, and has an ID. The registrations, what fields do they have? Well, you can have a registration date to keep track of when did you actually join a particular class. You can have an is wait list. Okay, so meaning that did you join the main class or are you on the wait list? And if so, there is a wait list position, which can be an integer. Okay, so let us code this other portion inside our database. Okay, so we need two more tables. We need a student table, db define table student. Okay, and the student table, we have all these fields related to a student, like field email, then it will have a field like first name, then it will have a field last name, it will have a field like student ID, which is perhaps an integer, but I can keep it stored as string, I'm not quite sure. And maybe it has other fields, okay? I don't want to flesh it all out. But essentially, this is a student table, and now I need my registration table. And it will be defined via db define table, and I will call it registration, and I will have a field. So the registration is of a student in a class offering. Okay, so it will have a student ID, which will be a reference to a student. Okay, it will have a field offering ID, which will be reference to an offering, to a class offering. Okay, so perhaps I should call this class offering ID if I want to be perfectly homogeneous in my names. And then it will be field is wait list, which can be a boolean, for instance. And then I can have field wait list position, which can be an integer. Okay, and I can have another field which is registration date, which is a date time, something like this. Okay, and again you can flesh out the details. So what is important here in this scheme of tables is the following. You should aim at not repeating information anywhere, right? Instead of folding, for example, the description of a class inside each offering, you should have the offering that refers to the class catalog ID, okay, and to the quarter ID in which the offering takes place. So you should split the information you have in various tables as needed to ensure that every piece of information is represented in only one place. This is essentially a practical test that tells you whether a database is correctly organized. Suppose you rename CSE 183 from web applications to web development. You want to have only one place where to make the change, and the place will be the name of the catalog class. Suppose a student changes their name. The only place where we need to change it now is the table student. Suppose you update a class description. Again, only one place. There is only going to be one record for CSE 183, one row in the database that you need to update. Okay? It works this way. And so, by the way, the class offering can also have other fields. As you refine your database and your information that you want to store, you can add a field, for example, taught by, and this can be like a reference instructor. And then if you do that, you would need to define an instructor table, db define table, okay, instructor, and well, let me copy here the instructor will have an email, first name, last name, and maybe other fields as well. Okay, but and so a database for a real application, usually grows larger, the description, because you have many tables, and for every table you have many fields. But the principle is this: try to split the information into independent tables and use this reference mechanism to refer from one table to the other. Along with deciding the structure of the tables, you should pay attention to what happens when you delete information. For example, suppose you want to delete a quarter, because, for example, that quarter the university will be closed. What happens if that happens? Okay, if I delete a quarter, let me use this highlight. Okay, so if I delete a quarter, what should I do to the class offerings that quarter? Should I delete the class offerings, or should I simply label them that they do not have any longer a quarter to which they refer? Okay, this choice is encoded here, okay, in the reference between a class offering and its quarter. So here you can say onDelete is equal to, and you can put a string. And for this string, you have various choices. The two main ones are set null, which means that if the quarter is deleted, you say that this offering has no quarter anymore. And the other one, which is the default, is cascade, which means that if the quarter is deleted, you are going to delete the class offering as well. Cascade is actually the default, so you don't need to put this, it's optional. So if you delete a quarter in this database organization, you would follow these, and you would delete also the class offering if you have set it to cascade. Okay, the cascade behavior causes this deletion propagation. Once you delete the class offering, the cascade again would cause you to delete the registration for all the students that used to be registered in that quarter. This, by the way, tells you also that when you design a database, you need to make a choice of how and when things are deleted. Sometimes you really want to delete information from the database by just removing it. You can decide that spring quarter 2021 doesn't exist anymore, hence this class simply ceases to exist and everybody goes home immediately, right? And there is no trace that it ever existed. Another approach would be to keep the class, to keep the quarter going, but simply to say something like enable, or perhaps better, you could call it active, okay, which is a Boolean status, so that you can keep track that Joe paid for the registration for this class that was supposed to be in spring, and that the class doesn't exist anymore, right? So a similar thing is for class offerings. Maybe you want to have an active bit so that you can remember that somebody registered for a class, even though maybe you want to mark that now that class offering is not offered anymore, but you want to remember that people registered to it so that they may, be able to get a refund for their tuition or whatever. Okay, so you could do that by saying here, for instance, field active Boolean, so will these take place, okay, so that you can have. So in general, you have a choice often in how to represent a deletion. So you can either delete things from the database or label them inactive or deleted via Boolean flag. And this depends really on the application.